morning Sotiotu, my name is Jasper Aurelius and I'm from class 8A, and today I'm going to talk about the Northern Lights. So actually the Northern Light itself is connected to the chapter of magnetic fields in the physics lesson in grade 8. So here are three really beautiful sceneries of the Northern Lights, which are found in Yellowknife, Canada, which is the first picture, and then the second picture is from Fairbanks, Alaska, and the third one is from Greenland. So actually, what's the Northern Lights? The Northern Lights is a natural phenomenon found in the northern hemisphere of the Earth, and it's also called as an aurora. And then the Northern Lights can only be seen with the naked eye in nighttime, and it's frequently found in higher altitudes of the Earth such as Alaska, Canada, Greenland, and Norway. So now that we've known what is the Northern Lights, I'm also going to explain about how does it form, how does the Northern Lights, or what you call as an aurora, forms. So this Northern Lights, or what you call as aurora, it is really affected by the strong magnetic field of Earth, which this magnetic field is projected out to space and creates this like round magnetic field that surrounds the Earth. So this magnetic field is mostly generated by molten iron alloys that are in the southern core of the Earth. So this Northern Lights is also really affected by the solar wind that's moving to Earth. So this solar wind contains plasma, and usually the solar wind is deflected by the magnetosphere. So when the magnetosphere is here and the solar wind comes, when it is not big, it will be deflected to the space. But if it's big and it's really large, it will be trapped in the magnetosphere and it will be deflected to Earth. And the solar wind that contains plasma, this plasma collides with nitrogen and oxygen molecules that is in the atmosphere. And this reaction with the plasma and nitrogen and oxygen molecules will make colors, and this is what we call as an aurora. So actually, different atoms of gas can also create different colors of these auroras. So actually, oxygen molecules emits greenish yellow or red light, while nitrogen molecules will give off blue light. And blending of these two gas molecules will produce purple, pink, and white colors. So despite of the auroras or the Northern Lights being so beautiful to look at, these can also cause some problems, especially when the auroras got really big. These really big auroras are caused by those very large solar winds that are trapped inside the Earth's magnetosphere. So these really big auroras can interfere with satellites and cause these satellites not being able to send back information to Earth. And the other problem is it can cause planes to alter routes because it might be unsafe for the planes to go near these really big auroras. But these really big solar winds that are trapped inside the Earth's magnetosphere, when these solar winds are too big and burst constantly to Earth, it can cause much more serious problems. One of the problems is it can cause every layer of the Earth's magnetic sphere to collapse. And the most dangerous problem that it can cause is to burn the whole planet. The whole Earth can be burned by this really big solar wind. So that's all that I can say in this presentation. Thank you very much. So till 2 and have a great day.